In this next section, we'll be finding the maximum and minimum values depending on whether we are using a sine graph or cosine graph. So we have the sine graph on the left and the cosine graph on the right. Now how do we relate reading the graph to our formula? Please note that there's an error and change all of the signs to plus minus signs. Now the maximum value of r sine theta plus minus alpha is r when theta plus minus alpha equals to 90 or pi over 2. Now how do we get r and how do we get 90 or pi over 2? Let's look at the sine curve. So we can relate our sine x to our r formula by putting the invisible one in front. So this represents our r, and our x is represented by theta plus alpha in our r formula. Knowing that our r is 1, looking at our sine curve, we'll see that our maximum value is also 1. Therefore, the maximum value is equals to 1, which is equals to our r. Now, when does this maximum value occur? So if you trace down, you'll see that it occurs when theta plus alpha, or x, equals to 90 degrees. That's how we get 90 degrees here. Now this is in degrees, and pi over 2 is just in radian. For the minimum value, we'll see that in the sine curve, it is negative 1, which is also negative r, since r equals to 1. Now when does this minimum value occur? We'll trace up, and we'll see that it occurs when theta plus alpha, or x, equals to 270. That's how we get minus r, and 270, or 3 pi over 2. Now likewise for the cosine curve. So we put the invisible 1 in front again, which represents our r, and our x is represented by theta plus alpha. So the maximum value of our cosine curve is also 1, which is equals to our r. That's why the maximum value of r cosine theta plus alpha is r. Now when does this maximum value occur? It occurs at theta plus alpha equals to 0, or 360. Similarly, the minimum value is negative 1, which is also our negative r, and it occurs when our theta plus alpha equals to 180. When we want to find the corresponding angle for the maximum value of r cosine theta plus alpha, there are two possibilities. So we need to choose the correct one. So the two possibilities are 360 and 0 degrees. When the r formula that we are using is theta plus alpha, we have to use 360. And when it's theta minus alpha, we have to use 0, or else our theta that we are solving for might go out of range. Because we have to follow the range where theta is between 0 degrees and 360 degrees. Now what do I mean by going out of range? So let's take using this as an example. Let's say we let theta minus alpha equals to 360 degrees instead. Now if we solve for theta, it will end up being our basic angle plus 360 degrees. Knowing that our basic angle is definitely more than 0, our theta will end up being more than 360 degrees, which is out of our range. Therefore, we need to choose the right angles. Now moving on to an example, find the maximum and minimum value of 2 cosine theta plus 3 sine theta and its corresponding value of theta, whereby theta is between 0 degrees and 360 degrees. So firstly, we need to combine our sine cosine function into a singular function. So using our r formula, can identify this as a and identify this as b. To find our r value, we'll use the square root a squared plus b squared formula, and we'll get square root 13. And to find our basic angle, we'll use tangent inverse b over a, so 3 over 2, and get our basic angle 56.3. Now deriving which r formula to use, we'll observe that cosine comes first. So our R formula will have cosine in it. Since our chosen formula has cosine, the sign will flip. So from minus sign to a plus sign. And this is our chosen R formula. So substituting in our R values and basic angle, we will end up with this. So now we have to find the maximum and minimum value. So we'll start off by presenting cosine theta minus 56.3 in an inequality. Because we know the maximum value of a cosine x curve is 1 and the minimum value is negative 1. And from then on, we'll times the whole inequality by root 13, which is our R. Therefore, we'll end up with our maximum value of root 13 and minimum value of negative root 13. And from then, we need to find the corresponding value of theta. So at our maximum value, corresponding angle of theta minus alpha equals to 0. That's why we will equate this to 0, and then shifting over the 56.3, we'll get theta equals to 56.3. Similarly, at our minimum value, theta minus basic angle will be equals to 180. Therefore, shifting the 56.3 over, our theta will be equals to 180 plus 56.3, which is equals to 236.3 degrees. Hence, find the maximum and minimum values of this new equation. Since it's a hence question, we need to use the answer from the previous part. So we can utilize how we've already presented it in the R formula from part 1. Now we will square both sides to form what we want in the equation, which will result in 13 cosine square theta minus 56.3. And then we'll add 5 on both sides. So to find the minimum and maximum values, we'll start with our initial equation of root 13 cosine theta minus 56.3. Now we know from the previous part that our maximum value is root 13 and our minimum value is negative root 13. We will then square everything, which changes our range from 0 to 13. The minimum value becomes 0 because there's a square, and anything square will always be more than 0. So after we square everything, we will then add our 5. So this 5 is resulted from 0 plus 5, and 18 is resulted from 13 plus 5. And now we have the new maximum and minimum values, 18 and 5.